The moving stone beneath the ice. Science, secrets, and the unknown. In the desolate white silence of Antarctica, where temperatures fall below 50 degrees C and the land sleeps beneath kilometers of ancient ice, something extraordinary was discovered. A stone moved, not rolled, not dragged, just moved. It wasn't an avalanche. There were no animals, no storms. Just a smooth, subtle shift, several feet across flat, frozen terrain. How could this be possible? This is not just a story about a rock, it's a story about nature's quiet miracles, the chemistry of ice, the limits of human understanding, and perhaps a message from beyond our world. The discovery, a silent shift. In 2019, a research team led by Indian glaciologist Dr. Meera Joshi was stationed at a remote Antarctic site, observing climate change patterns. The goal was simple: monitor ice thickness, wind behavior, and surface temperatures using automated drones and time-lapse cameras. But while reviewing footage, Dr. Joshi saw something puzzling. A rock, once captured at one location, was found several feet away a few weeks later. The surface was smooth, the area untouched. No melting trails, no wind streaks, no tire tracks. It looked as though the rock had decided to move by itself. Was this a camera error, a prank, a misreading? The team double-checked everything. The footage was real. The GPS data accurate. The rock had moved. The science behind the motion: ice rafting. Eventually, the team found an answer, though it required some very precise chemistry and physics. The phenomenon is known as ice rafting, a process in which rocks or debris move slowly across icy plains due to thin films of meltwater beneath them. Here's how it works. Daylight melting. Even in Antarctica, sunlight can warm the surface just enough to create a microscopically thin layer of meltwater. Night refreezing. At night, temperatures plummet again, freezing the water and slightly lifting or shifting the ice around the rock. Wind influence. A mild but consistent breeze, often no more than a few km/h, can push the thin sheet of ice carrying the stone. Surface chemistry. The molecular structure of ice, hexagonal crystal lattice, allows for quasi-liquid layers to form even below freezing point, reducing friction. Cumulative motion. Over days, weeks, or months, the rock glides inches at a time, eventually covering several feet. This combination of thermodynamics, surface tension, and kinetic energy creates a system where the rock is not dragged or pushed. It simply slides on its icy raft. It's not magic. It's delicate chemistry, physics, and time. The geological significance ice rafting isn't just a curious anomaly. It plays a key role in sediment transport. It helps move rocks and debris across continents and seafloors. Climate clues. By analyzing the movement and composition of ice-rafted debris, IRD, scientists can reconstruct glacial activity from thousands of years ago. Erosion and deposition. It shapes the landscape, affecting how valleys, ridges, and lake beds form beneath glaciers. Ancient myths and unexplained patterns. While science offered a rational explanation, something still felt odd. This wasn't just one rock. Multiple rocks in the same area showed strange motion paths, some even moving in coordinated loops or geometric curves. It reminded some researchers of racetrack playa in Death Valley, where stones move mysteriously across a dry lake bed, leaving trails behind. In Antarctica, however, there were no trails. Dr. Joshi began to wonder, could it be more than just wind and ice? The alien hypothesis, a message in motion? Let's be clear. There is no direct evidence of extraterrestrial involvement. But the moving rock sparked speculative theories among fringe scientists and enthusiasts. Electromagnetic interference. Some stones only moved during high atmospheric EM activity. Could they be responding to invisible signals? Mathematical symbols. The pattern of rock paths appeared too symmetrical to be random. Circles, arcs, and precise angles. Were they glyphs? Satellite blind spots. Curiously, satellite footage over this region was often blurred or missing, raising suspicions of deliberate obfuscation. Subglacial structures. Under Antarctica's ice lie unknown formations, some metallic, some geometrically perfect. detected via radar but never fully explained. Could an ancient civilization, or perhaps something otherworldly, be experimenting beneath the ice? Are these movements natural or orchestrated? While mainstream science remains skeptical, the coincidence is intriguing. Dr. Meera Joshi's reflection. Between science and soul. In her final expedition notes, Dr. Joshi wrote, "I came here to measure melting ice. Instead, I found a stone that moved and reminded me that nature holds stories far deeper than data." She continues, "Maybe it's wind, maybe it's water, maybe it's a force we haven't yet named. But in this silence, even a stone speaks." The metaphor, life beneath the ice. The moving stone has become more than a scientific curiosity. It's become a symbol. In a world where we often feel stuck, in grief, in isolation, in uncertainty, this stone reminds us, movement is possible, even in frozen places, even when no one sees, even if it's only an inch a day, because beneath the silence, beneath the ice, something is always shifting. Conclusion. Between fact and wonder, is the moving stone simply a result of cold chemistry and gentle physics? Or is it part of a larger mystery, connecting geology, history, and perhaps even messages from the cosmos? Maybe it's both. Because the universe doesn't always speak loudly. Sometimes it whispers through ice and moves a stone to remind us that even the quietest journeys matter.